You and I have been plugging in electrical power cords into electrical outlet receptacles our entire lives. But hey, let me show you something. You notice these little holes here on the prongs on your electrical power cord? Have you ever wondered what these little holes do? What are they there for? What do they do for us? And if you look here, you can see these holes appear to be on every single type of electrical plug, whether it's a 3-prong plug or the 2-prong plugs. No matter what, the holes are on every one of these. Now, we get questions from people from time to time about why these holes are in your electrical power cord prongs. And sometimes when people try to answer it, they'll assign the origin of this to the wrong inventor. So we're going to clear all of that up for you as well. Now, some people have a theory on why these holes are here on the prongs on your electrical power cord. And they say in their theory that it's because when you plug it into the electrical outlet over here, the receptacle, that there's pins inside the receptacle that will grab onto these holes right here and prevent your cord from being pulled back out, like a safety feature. So do you think that's true? But let's test that idea out. You have your power plug here, you plug it into the outlet receptacle, and there's nothing holding it in place. It just comes right back out. So a lot of people think that there's some kind of pins inside there that might go inside those holes when you plug in your prongs, but that's not true. See, your plug just pops right out. So we've debunked that theory. Okay, now, some people think that these holes were put on these prongs here to save money during the manufacturing, and I'm thinking, that's just a really stupid idea. I mean, as an engineer myself, I can tell you that's a really dumb idea. Because if they were gonna put a hole in here, why not put a long slit and make it even bigger and save even more money, you know? So dumb ideas like this come from people who want to try to impress you with their knowledge. They think, oh, I know something that you don't know, or I'm thinking outside the box. Well, unfortunately, their box is flattened.
Let's go, Inventor.
Now, other references covering this topic will actually incorrectly assign inventorship to this guy right here, Harvey Hubbell. He's an electrical inventor from the very early 1900s, and many of them might say that he's the guy that invented the holes in the blades of your electrical power cords, but this is incorrect. Harvey did not invent the holes in it. Here's what he did do, I'll show you because it leads into it. Some of Harvey Hubbell's earliest inventions, though, did indeed lead to it. So here's one that he filed back in 1903. So this is like a light socket here that had the plug. So here's the socket itself, the housing for it. And then the bottom part here with the wires is the plug. And here's the two blades that lead up in there. And you can see how they just plug into place. So as we look in at his patent and take a closer look, you can see it was just a very simple plug-in, and it was held in place by the clip. So here you can see it's got this locking spring contact there. Now he doesn't have a hole in the blade. What he has is these notches. This was his design here. On his second patent that he did here, let's see what the date of this. This was filed January 2nd, 1912. Here you can see he got a lot better at his drawings and more clearer about what he was trying to do. So look at the side of the blades. You see how you got these notches here, number 16. So here's two different views of it. Here's the side view, and then down here on the lower left is sort of an angled isometric view, but they're both pointing at number 16 here, which are the recesses in the blades. It's a flat blade with a U shape. And this is supposed to plug into here, into the socket there, and it's supposed to engage with number 18 here, with these lugs. So you see how you get these little lugs? 18 is one on the right and there's one on the left. So when you take the plug and plug it in, and remember, here's your number 16, here's where the cutout is. When it goes all the way in there, it's supposed to engage with these lugs. So this was his envisioning of the invention for Harvey Hubbell. So this here would later evolve with other manufacturers to become the current standard that we have now, and we'll show you how that happened. So here's another patent here that looks like it came out in 1915, and this is when he came up with the first plug that has a polarity, because you can see one is bigger than the other one, right? Just like on our modern day plugs. And just like before, the plug was meant to insert here into the clips, and this indent on here was meant to engage with the indent hole that was on the plug blade. Now, several years ago, I was an electrical engineer at Motorola, and yes, even I have a patent to my name as well. So the problem that you're going to see developing here is the same that we always faced at Motorola, is you're looking at the competitor's patent there, and you're saying, okay, his patent covers this. How can we do this without infringing upon his patent? Well, if he's going like this, let's go from this way. So they came up with a method. Let's put a hole in the middle of the blade. Remember, Harvey Hubbell's patent covers those little cutouts there on the side of the blade. We're talking about a hole that goes right through the middle of the blade. Okay, so here we can see in the 10 trademark reporter, here it was in October 20th, 1919, Harvey Hubbell sued General Electric as one of the manufacturers. Or you can see right here, imitating structural elements. And there was another one too, imitating physical characteristics. So right here on the end of his summary, the judge says, I am satisfied that there is no such palming off or even copying of the physical exhibits as to present an actionable wrong. There is no copying of lines. So here he says, for these reasons, a decree will be granted to the defendant. So this means that Harvey Hubbell lost the case. So then in 1926, all the manufacturers got together and they formed this entity called NEMA, which is the National Electrical Manufacturers Association. And these guys decided, you know what, if we're all going to be making stuff that works, we want to make it all work together. So they set out to make these standards that will become what we have today. Okay, so those standards led to these NEMA connectors. So when you go into the store and you buy outlets or plugs, you'll look and you'll see things like this on there. So here's your standard typical 120 volt AC outlet, and it will say NEMA 5-15 on it. Normally it'll say R for receptacle, or it will say P for a plug if you have a plug, but this is what you're used to seeing here on the wall. And that's why everything works together, because they made these standards. So for example, here's your clothes dryer. If you're using a more modern 4-conductor clothes dryer, you're likely to see this one right here. This is the one you've seen me do in several videos. And then here's your oven one if you're using a 4-conductor oven. And those of you that have AC for 240 volts, this is what you're typically going to see. Most of you have never seen the welder or cutter ones before, unless you actually do welding. And here's a more comprehensive chart right here of the NEMA receptacles. And here you can see they're numbered a little more accurately here. See, that's a receptacle, and this is a plug. And so this is what it looked like. This is the Series 1. This is what it looked like back up until about the 1960s, when all we had was just the 2-wire. So if you live in an old house up north that just has 2 wires like this is what you're going to see. But sometime in the 60s, they made that change over to these 3 conductors here. So nowadays we use these 5-15Rs like we mentioned. But again, what about these holes? What are they doing there? Let's take a look at the spec and see why they are on there. All of the engineering standards bodies, when they file a spec, they usually like to do it through ANSI here, because it's the approved American National Standard. This is called the ANSI NEMA WD6 spec. And this one is from 2016. There might be newer ones, I don't know, but this is just the first one I found. And this is a spec right here, as you can see, for wiring devices and dimensional specs. So this is why whenever there's questions as an engineer, I'm always asking people, okay, what does the ANSI spec say? Let's go check it out. You can see the ANSI spec covers things like about the dimensions of the outlets. Those things all have to be very fixed. Otherwise, you could have errors. You know, when you buy a plate, a mounting plate should work. Okay, so this is where I'm the most interested right here, is on page 17 of the ANSI NEMA WD6 spec that covers the flat blade hole locations, the general information. So they're telling you, here's the drawing. So every manufacturer in the entire United States that wants to make a plug that has to fit in everybody's outlet, it has to look exactly like this. You can see right there, it's an 1/8 of an inch hole, as they're pointing to the hole right there in the middle of the blade, and it says hole location. It looks like it's dead center vertically, and here's the distance that it has to be from the end of the cap. Go with a bigger one, with the bigger blade, there's a slightly bigger holes, about, looks like probably almost twice the size there. And they even have a blade hole location chart depending on what type of connector you're using, what type of plug. Now right here is the clincher, folks. Look at this note that they put here on this page. It says, note, hole in flat blade is optional and is intended for manufacturing purposes only. However, if used, it must be located as per dimensions shown above. So there it is. They're telling you right here, it's only used during the manufacturing process, and it's not used for anything else, and you don't even have to put the hole on there. So why do all the manufacturers continue to put the hole? My guess is likely because when they go to make their design, the mechanical engineers are looking at this spec and they're seeing the hole there and they think, oh, the hole has to be there. But how many of the engineers, I wonder, actually notice this? Maybe they don't want to be different from other people. Maybe they're afraid the end users will pick up this plug, not see the hole in it, and wonder if there's something wrong with it. So you see how you start a snowball effect here, because somebody created a standard and everybody else has to follow it now. So this is pretty interesting to note here that the hole in the flat blade is optional and is intended for manufacturing purposes only. So you can see the power of having standards and how good they are for you in the industry, especially in the computer and high-tech worlds and electrical worlds like this. For example, if Android wasn't a good standard, how would any of you have apps that run on your phone? You know, you wouldn't be able to operate on it. And the reason why they do is because they all conform to the spec for Android in order to make those apps run. This is why you never have to worry about whether you're plugging in your blender or whether you're plugging in a can opener or whether you're plugging in a food processor. No matter what you plug into the wall, everything you've ever plugged in your life will plug into that outlet without any problems. And that's because of this standard. That's what protects you and me, so that we know we don't get anything proprietary from one company that isn't going to work. They all plug in.
So it seems like the standards body here went through all of this engineering work, making all of these drawings, these ANSI type specs and everything, all for nothing, for something that we're not even using. What a waste of engineering efforts. So there you have it. At least we got the answer. We know that we're not using it for anything. Who would have known? So anyway, thank you so much for joining us on this video today, folks, and we'll see all of you on the next one.